we go. All right, welcome everyone to the talk. The talk, as the title says, and pretty long one, is Hack the Source, Securing Open Source Software One Bug at a Time. And so we are not going to disclose any open source 0 days here. So if you're expecting that, it's time to kind of make that clear. What are we going to talk about? What we're going to talk about is basically looking at open source programs on HackerOne. Okay, so I'll be talking a lot about HackerOne, bug bounty programs on HackerOne. And in the past, we've talked a lot about regular bug bounty programs, wherein we focus on dynamic web apps, dynamic mobile apps, and other assets. But today, I'll be specifically focusing on open source programs and why it's needed, how can we approach it, are there bounties at all or not? So yeah, we'll look into that. My name is Sandeep. I work for HackerOne. All right, so what do we have today? Why should we care at all for open source bug bounty programs? After all, they don't have the money. So yeah, why should we care? So open source targets that are available on HackerOne to target, and I'll go beyond that as well. It's not just HackerOne, but there are other places as well. You can find open source programs, open source projects where you can use all your skills to kind of, find bugs and kind of report to them. Then once you've found your open source targets, how would you approach open source targets? Like what methodologies you can build? Again, in a 30-40 minute talk, I cannot go deep, but I'll give you like a very bird's eye view of what your methodology can look like. You can take that home, build your own workbenches, start building out your methodologies and start focusing on them. And then I'll introduce you to something called Internet Bug Bounty, which in short, what is called IBB. I'll talk in detail what that includes, how does that works. So like I said, after all, open source projects don't have money. So we are trying to fix that using Internet Bug Bounty. And how does IBB works? So we'll go into that. This is roughly the agenda for today. All right, so the first question, why should we care? And this is fairly a common knowledge now. This is not something new that I'm telling you. All modern digital infrastructure is powered by software supply chain that consists of a lot of open source projects that we use. And anyone who's worked in a development shop or in product security kind of environment, you're aware of the nightmares that Node.js dependencies brings in environment these days. That's just one example. So there are many others. Open source software represents a growing portion of the critical attack surface as well. Like the more attacks that you hear, mostly around supply chains, are caused by open source dependencies. And you might have heard about primary, secondary level of dependencies as well. Like your software is relying on a dependency that you can track and kind of, work and fix. But that library that you're relying on might be relying on something else as well. So that's like secondary, I would say, dependency, secondary level of dependencies. And so it keeps becoming pretty complex pretty soon, the moment you start digging into it. And so just as open source software is enhanced through the community, there are like lots and lots of community contributors who make those open source softwares work. I think, and it's pretty kind of understood that community should also play an important role in securing it as well. And like at this conference, most of us are here, like, on the offensive side, defensive side, mostly offensive side. So yeah, by finding bugs in open source softwares. And of course, bug bounty programs can help facilitate that whole finding bugs and rewarding bugs thing. All right, so open source targets. So when you go on HackerOne, all you have to do is go to hackerone.com opportunities. You can asset type select by source code. The reason it's source code is all open source softwares will have their source code in public, and you can filter by that. You'll find lots and lots of projects. Some projects have their own bug bounty program. There are projects like commercial projects as well, like Elastic, for example. So Elastic would have its own bug bounty program running on its source code. Then you'll have some vulnerability disclosure programs on open source projects. You'll find projects like Kubernetes, you'll find projects like curl, you'll find projects like Node.js and all those kind of things as well, which you can target. I'll come to it in the later part as to how programs are grouped into like, paying for those bugs and all those kind of things. So yeah, this is the way. All right. So once you've now this is where we pivot. So doing bug bounty on open source program would be slightly different in terms of you can always start building recon, taking recon approaches, going to GitHub advanced searches, looking for PRs, etc. But that approach we are not taking here, because by searching for these open source targets, we are specifically going to kind of build a methodology to focus on one project at a time. And let's say give a lot of time to one project rather than, hunting for bugs across like the whole open source pool. Let's say go to GitHub and do queries and all that. That we are not going to do. We are going to look at the code base. So from here, we'll kind of move on to a part wherein we'll primarily focus on the source code that we are targeting and what methodology can be built. Okay, anyone here? I think we may have a lot of people who might have already done a lot of code review. Can I get a quick show of hands? How many people have done code reviews? Okay, pretty less. I was about to say pretty lot, but then I stopped. No, there are no questions coming. The talk is not technical at all. So yeah, I will set that middle talk disclaimer. So it's just to help you. The takeaway of this talk, and it's in the middle that I'm saying, is to understand what is available there to hack in terms of open source programs. What is the very high level methodology that you can start, where you can go, how you can start building your kind of, workbench. So, okay, prepare. The first thing, let's say you choose a open source software, you choose a program that you want to hack. I'm not coming to the bounty part yet. I'll come to the bounty part later, because, when we set the bounty conversations in the beginning, then the conversations become different. So, we'll start with preparing. Like the very first thing of preparing or going into a code review kind of thing is that you should have a good code editor or an IDE. And what good code editor means is that you should have functionality to search through the whole code base in the code editor. You should have functionality to search using regexes. You should be able to kind of, match with multiple files, some file name patterns. You should have good pattern matching in the code editor. The reason I don't name a code editor, of course, when I say all of this, Visual Studio Code stands out. So a lot of people use it. And then there are others as well. Okay. So yeah, first build a good code editor, have a good code editor, build your kind of comfortability around that, searching, pattern matching in those code editor. Be good with regexes as well. Have a fairly good understanding of regexes and how they work. You should also have an environment to create tests and test your hypothesis. Like if you have a certain test case that you want to test, and if you're able to compile the code in a certain environment and then test that, that's certainly useful. So that's kind of important. Know your code. So any code base that you will start to look at, you'll have to spend a lot of time, and I say this that, when doing code reviews, there is no alternative to reading code. You'll have to read it. Okay. You'll have to spend time reading it. You'll have to understand what the program is, what the code base does, what functionality does it serve, where are the key functionality, the code bases around the key functionalities, which users what kind of users does this program have, or like this code base will have in general. What are those users supposed to do? So you'll have to build your own threat model for the open source software that you're trying to kind of, hack into. And then based on your own threat model, you can start targeting those particular areas of code in order to kind of find bugs. And yes, there is this whole conversation around coverage of code. Like if it's a big project, if you have like millions of lines of code in that project, how would you cover everything? But what we are primarily focusing on here is how to find bugs, or where you'll mostly end up finding bugs. So yeah, know your code. That's really important. A lot of times we get this question like, is knowing a programming language important to do code review? Yes, of course, one would say 100% important. Now the question kind of goes around like, should I be able to write code? This is an evergreen question. A lot of people ask this question when doing hacking as well, like, learning security as well. Yes, when you're doing code review, I would say, yeah, knowing a programming language is really important, and knowing how programming works in general is important. Now, you don't need to know every language, even, okay, what went wrong? Okay, so knowing a programming language is good enough. If you coming from a legacy C world, you're probably the safest in this world. And if you're more of a modern like programming language person, that's also good, because a lot of concepts do carry into these kind of different programming languages. So yeah, you don't have to sweat about like, there is this new language, Rust in the market, there is Go in the market, and I've only coded in, let's say, like JavaScript, Python, nothing much, or Java, maybe nothing much. Know vulnerability types and how they look at the code level. Now, this is important. A lot of people who generally engage in bug bounty, they're looking at applications from a very dynamic perspective, what it looks in the front end. You intercept request responses, and that's it. You play with those request responses a lot. But you should be familiar with what it looks like, what the code level looks like for any vulnerability type. And how you can build that, you can always look for vulnerable applications. You can go to their code bases, read their code, and see what the vulnerability looks like. You can also, this is a very interesting thing, and that has helped a lot of people that we've spoken to, is you can go to the open source projects, you can look at their PRs, the security PRs, the bug fixes that have gone there, and look at what bug was it solving, what did the code look like. And that's the beauty of open source. Like, you can always go back and kind of, look, and that is probably the best learning source if you want to learn about like, how does bugs or vulnerability types look like at the code level. Concepts, there are concepts, code review concepts that you should definitely be aware. Things like, anyone aware of things like source, sink, things like that? Okay, so yeah, things like sources, sinks, where you're taking the input, how is that input being processed, and where it's kind of converting into an output, or like what is the final outcome. So know those concepts as well. And like I said, read the code. There is no replacement of reading the code. Learn more about the language. So if you've, let's say, picked up a project which is in, let's say, Ruby, okay, and if you have to spend a month in that project, it's good that you learn more about the language. You learn more about the libraries. Now, someone who is implementing a project which is written in Ruby, and then they're kind of looking at all the dependencies, the libraries, etc., they have a lot of time. But as a bug hunter, as a bug finder, you will not have a lot of time. And that's where the fun comes. You'll also have to learn about those libraries that a lot of software developers end up spending a lot of time with. Learn those libraries, what those design patterns are, kind of how they look like, and all those kind of things. It's really fun. Like, when you start it, you spend like a month or two, and you learn the reason I kind of keep bringing this up is because, except the bounty part and except the other things, there is a lot of learning every time you get into code reviews. Any questions before we move ahead? Okay, we'll take questions in the end then. We'll take questions in the end, probably. I think we have a good time. Okay, then now this is pretty standard. Like when we talk about code reviews, there are standard things like static analysis, dynamic analysis, manual code reviews, etc. That's done. But what I'm largely talking about is what we've kind of tested in open source projects that we see on the platform, as to what kind of leads to finding good bugs, okay, or decent bugs. And some people would think that, these open source projects would have a lot of eyes on it already. So like, would static analysis, things like static analysis yield anything or lead to anything? They do sometimes, okay. And it's useful when dealing with large code bases. Of course, you'll not be able to read through 400,000 lines of code yourself. So building out like a good static analysis test bed, and I'll not be talking about any commercial tool, but I'll come to the later slide as to which tools you can use for static analysis. But it's also good for someone starting out code review. Okay, like all the leads that it throws at you, you're reading about that, going into kind of, reading the analysis results would also give you a lot of information. A big complaint around static analysis, and I don't know why as a security industry we've not solved this, is it's a 20-30-year-old problem, is the false positives around static analysis or static review, static code review. as a tester or as a bug hunter, there are ways you can kind of overcome some of those, but not fully. You will, and some tools, not all tools, would give you options to configure your trusted inputs in the scanner or in the tool that you're using. You can always configure your trusted inputs as to this particular piece of code or this particular functionality. Starting from this particular source is not kind of, is a trusted place. Don't give me bugs here. Exclude unneeded codes. There are a lot of test codes as well in repos, etc. Just exclude them, because you'll always end up finding a lot of bugs in test repos and all those. The limitation around static analysis is pretty well known. They're unable to detect specific bug classes like business logic issues in applications. In code bases of applications, they'll not be able to detect. Things like IDOR, they'll not be able to detect, most likely. Okay, not saying 100% of the times. Tools that are available. The most kind of common or the most well-known or most talked about thing these days is CodeQL. It has a support for a lot of programs, but it supports really well C, C++, C#, Go, Python, Ruby, these kind of languages really well. It supports others as well, I think, but the support is not that great. And it's owned by GitHub, but it's free for your own research and free for open source projects. So you can run CodeQL on open source projects. And few of you might be aware, GitHub also runs a bug bounty on CodeQL queries. So if you run it on your project that you're testing, and if you write a query for detecting a specific pattern, and if you submit that query to GitHub, they'll pay you a bounty for that, just for the query. Okay, so they want to improve that. LGTM is, again, it was a different product, but it's now bought by GitHub, being used by, it's a SaaS kind of thing. You can just go and upload your code repo there, depending on how much you want to play around that, and it will throw out a lot of results. CodeQL and LGTM together are kind of good. LGTM is getting merged into GitHub now, so it's like GitHub code scanning or something like that. There is these are all free, and most, if not open source, I think, no, they're all free to use. Yeah, not all of them are open source. Brakeman, it's pretty good for Ruby. On their website, they also have a documentation around checks, like what checks do they perform. And those are also a good place to kind of, learn as to what issues might occur in Ruby based projects. Salm, PHP based. This is a static analyzer. So you'll have to use something called taint analysis, a plugin called taint analysis, or like an option called taint analysis to run security related checks. A lot of you, or some of you, might be aware of something called find sec bugs. But the bigger static analyzer for Java is Spotbugs, which is a fork of FindBugs, and they have a plugin called FindSecBugs, and it also, I think, integrates well with Maven and Gradle kind of environment as well in a Java world. So yeah, Spotbugs works well. CPP check, as the name says, it's C/C++. So you can see it's a pretty good coverage of most of the common languages. There are languages not listed here, but you can start with these. Like, these are free to use. Run these scanners on the projects and analyze the results. Not just that, you ran the scan, you didn't find anything, that's it, I'm going home. No, you'll have to read through what it's throwing at you. Okay, and that's a good knowledge building exercise. Of course, a lot of times it might give you some lead as well as to where, for example, if there is a specific portion of the code or specific functionality where it's throwing a lot of leads, you might want to go and just inspect that whole functionality, read the code base yourself manually. Okay, manual analysis. Scope where you want to focus. Now, the reason I say scope where you want to focus is there would be big projects. You will not be able to read all of the project's source code. So the places, and that's why initially I said build your own threat model, understand what the code base does, which are the major functionalities of the code base, and build your own threat model. Read the code. Once again, I keep saying this all the time. And there is something called targeting code bases based on metadata. Like, you build your own metadata. Okay. there are some, you can do a differential analysis on code bases and find out which are the old parts of the code. You might end up finding something at code bases which are pretty old, or parts of the code which are pretty old. Based on complexity, you can run complexity tests using SonarQube, Matrix++ kind of tools, and you can find, so more, again, no guarantee, but a lot of times complex code is where developers might end up making mistakes. So you could go to places like, find complex codes using complexity tests and go in and manually review them as well. Parts of code written by certain developers. This is a pretty kind of weird thing that I've added, but a lot of folks or bug finders would go and look for history of bugs in a particular project, and they'll see that there would be some contributor or developer whose code, the part of the code that they wrote, has always ends up getting bugs. Okay, because it's open source, it's not a very standardized way of contributing and all that. So they'll target the codes that are written by those developers. So that's also one way you can look at, like, targeting based on metadata. Target based on functionality. Again, go to places where authentication part, authorization part is kind of there, exists. Go to specific functionality, upload, download, pretty standard. Places where serialization is happening, deserialization is happening. Those are the places where you can kind of, start from the source, go up to the sync part and see how it kind of goes. Manual analysis continued. Okay, so there is a big problem in code bases around, like, problems occur at boundaries most of the time. And again, I go back to my earlier thing that I said, when you build your threat model, you will understand where your boundaries are in the code base. And there you can then focus on the boundaries. Like, if there is an external authentication module using SAML, Auth0 kind of thing, if there is an external payment system, or if it's relying again on a third-party library, inter-process communications, things like that. So you'll have to find those boundaries, focus on. So this way, by following the entire approach, you've limited a lot of places that you need to go, that you need to target and find things. And make use of editor heavily. When you're doing manual analysis, make use of editor and consider it your manual review tool, I would say. All right, so that's a very bird's eye view of what methodology could look like. It could differ based on language, it could differ based on project, or what exists, what doesn't exist, and those kind of things. This is purely from a bug hunting perspective. The methodology could change if you're running a SAST kind of engine in your company. The methodology would change if you're doing, let's say, a coverage-based code review engagement. But this is these open source projects, they exist and they need eyes. Okay, they need more eyes. So the more eyes go and target specific areas, there are chances that there will be people end up finding bugs. Okay, so that brings me to the final part, which is I want to introduce something called Internet Bug Bounty. This is a project that HackerOne sponsors and runs. It's a project to secure shared software components by pooling defenses, okay? And right from discovery to remediation. It's not just about rewarding bug hunters. The way it works is, I'll come to it. This is the page, I'll come to it later, I'll show you. Okay, the way it works is you have open source software, you have a program on open source software getting enrolled to Internet Bug Bounty. Once they've enrolled to Internet Bug Bounty, there are sponsors, and I'll come to sponsors as well. And using the funds that sponsors provide, if a bug hunter finds a bug on those open source softwares that are enrolled in Internet Bug Bounty, will end up paying a bounty. The 80% bounty goes to the bug hunter, the person who's found the bug, and 20% of every bounty goes to the project maintainers, the project itself, to facilitate the remediation, the efforts around remediation, and all those kind of things. Right now, the launch customers are basically the sponsors. So this is sponsored by 5 companies: Figma, Facebook, TikTok, Elastic, Shopify. The way it works, I'll come to it as well. And the projects, there are 18 projects in scope. There are $500,000 which gets committed every time, and that gets consumed. I think so far we've already paid around a million plus, or if not million plus, it's roughly around $1 million that we paid. The projects in scope are Electron, Node.js, Nginx, Curl, to name a few. There are others as well. We recently onboarded Apache Foundation after the whole Log4j fiasco as well. So they're there as well. How it works? Okay, so this is how it works. So there would be bug bounty programs for like companies who are using a lot of shared software components which exist in the open source. They'll commit 1% of the bounty that they pay every time to this pool. And that the whole pooling kind of keeps happening, and the funds kind of keep getting added to the Internet Bug Bounty program. And then those funds are used for kind of paying out. Now, the life cycle. You can see there are hackers, there are open source projects, and they're supporting partner, the people who are sponsoring. And then there's this whole open source software. Okay, so supporting partners, giving money to the pool, hackers finding bugs in open source projects. You'd need, in order to get rewarded, you need to have an advisory or a CVE or any kind of public advisory from the open source project would work. Once that happens, the Internet Bug Bounty ends up paying both to the open source project and both to the hackers as well. The 80-20 split. Okay, so how it works again. Now, this is roughly the life cycle. A vulnerability is discovered in a project. You don't report it to Internet Bug Bounty. You've seen which projects are enrolled in Internet Bug Bounty. You go and work on those projects for a month, 2 months. You find something worth, you report it to the project maintainers. Okay, the project maintainers will then fix it, will acknowledge, triage, remediate, fix everything, and then they'll publish a security advisory. It could be a CV, it could not be a CV. That's absolutely fine. Then once an advisory is published, the finder will claim the reward from IBB. So they'll submit the same bug to Internet Bug Bounty and say that I submitted this bug to this particular software project, and they fixed this bug, and this is part of your program, so I can be rewarded. Then if the reward is for $25,000, the finder gets $20,000 and the project gets rewarded $5,000. And from the partner bounty pool, so this is not very kind of important, but from the partner bounty pool, there are like 50 chunks of $500 that gets deducted every time kind of that happens with this kind of thing. So, yep, that brings me to the end. Some of the takeaways, like I initially said, the major takeaway is there are lots of open source projects that exist on HackerOne. From a bug bounty perspective, there is this whole program called Internet Bug Bounty. This hosts the major softwares that we use in our day-to-day lives. You can find those projects, find bugs, and claim your reward. The methodology is pretty high level that I discussed, but I am planning to publish a detailed blog post around this, which would probably come later in the month. So yeah, with that, I can take any questions. Yeah, you can come. Yeah.
Good afternoon, sir. As an young bug bounty hunter, what will you advise? Like, what are the mindsets you suggest to an young starting? Like, I am starting into this. So, how would you advise, and how to keep my mindset going on, and how the motivation should bring in? Can you please explain that?
Okay, yeah. So the talk was mostly around open source softwares. These are pretty hardened, I would say. So you should not start your bug bounty journey with open source software. If you're already a kind of an experienced bug bounty hunter, then I would say you can start, pivoting into the open source softwares, read code, understand code and kind of, build your experience around that. But if you're just starting out, the thing is you'll first have to get your concepts right. Okay. So spend a lot of time building your fundamental skills, concepts. You don't have to really go and start doing bug hunting immediately. But if you have all the fundamentals and if you're confident that now you're in a good position to find bugs in things, go and start looking at vulnerable applications. How comfortable are you in finding bugs at deliberately vulnerable applications? If you think you're doing good there, then you start going into easy programs, like, which are not looked at really, like which don't have a lot of engagement. You can find those. Don't go for rewards immediately, but see how confident you are in skill. And I think that's probably to start with. Yeah. Okay.
Sir, it's okay. Sir, distinguish between. Okay.
Do we have any other questions? Yeah.
So as a part of product security engineer, we face this question a lot of time. The developers wants to use that open source software or that. So is there any sort of assurance level program or that is existing, which gives some sort of rating on the open source project, like this have been thoroughly tested or this have been gone through this level of testing? And the bugs that are being reported through the bounties or through their those are being remediated, and the commits are being regularly fixed, right, at a frequency. So is there something that you know, or you have something in mind, how to actually recognize, okay, this is good to go ahead with this open source?
The answer depends, because it depends on what project you're trying to use. Or let's say if you go for something like, OpenSSL, Node.js, these are pretty heavily used projects. You'll be able to see what bugs are reported, what kind of, I think they also document that they've gone through the security tests and checks, etc. Sometimes there are places like Linux Foundation, Open Source Software Foundation, who run these checks for these kind of projects. So while some projects will have a well-documented history, like for example, not sure, you might have heard of something called Argo CD, and the CD kind of tool. They recently went through a big threat modeling exercise and they published their threat modeling report. So those kind of things you can find for well-known projects, but the more less maintained projects, the projects that are, you can say, technically are run from garages of people, you'll have to do your own check. And that's where the responsibility on open source comes, is that if you're using it, if you think that that's useful, you can allocate some of your resources in looking at that as well and contribute it back. Through bug bounties, if they have, for things like Internet Bug Bounty, these are all public. So all the bugs that have been reported, you'll be able to see in a particular project in a public way. But security assessments, assurance exercises, code audits, not a lot of open source projects can afford that. And only the ones that are big, are sponsored, are well funded, will be able to afford it, and that will be there publicly available. But if you're making use of a smaller open source project in your company, I would 100% say that, allocate some resources internally to run that whole assurance check yourself as well. That's the only way to go. Yeah. Okay.
Hi, Sandeep. Actually, I have a query regarding, let's assume you have an application which is using a well-known open source software, but the situation is that you reported a bug to the maintainers, but maintainers are not responding. And until they respond to your PR or whatever the bug you have reported, you won't be able to approach the hacker one for the bounty itself. So is there any way around, if the maintainers are not responding, you can approach to you guys and then probably get that fixed?
Okay, yeah, that's a good question. So if you come across a scenario wherein the program is enrolled in Internet Bug Bounty, you've submitted a PR or you've submitted a bug, but they're not responding, and not responding is a pretty subjective subject again, how long have you waited? But I would say roughly, 30 days, 90 days is the max. 90 days you can wait, at least for a response. If they've not responded, and if the project is already enrolled in IBB, I would say you can reach out to ibb@hackathon.com, and we can also facilitate that conversation with the projects, because we closely work with those open source projects. So we can facilitate those conversations if a bug is open and they've not. And most of the time, I mean, I have total sympathy, and I always keep saying with the open source project, is because most of the time, even the bigger projects have a lack of resources. And that's why we want to, like, we try to commit that 20% of the bounty pool to them, so that, you know, they can use some paid work as well to kind of get those done. But yes, if you come across any of those, you can always reach out to ibb@hackathon.com. Okay. All right. Okay.
Hi, thanks. I was wondering, we all know open source has problems with financing anyway, so the split is nice, but what stops open source like being motivated to continue to write secure software if they could actually get more financing from the 80-20 split than they usually get?
Yeah, so that's a good question. Secure development is a problem, and you might have seen the State of Open Source Security report that Snyk publishes along with a lot of like non-profit organizations. And state of secure development is a problem in open source as well. But state of secure development is a problem everywhere. Okay, so it's I would say, you know, I'll not be like there is no discrimination. I think it's roughly the same. Like any secure development problem that you see everywhere else inside closed organizations as well, the problem would be higher for open source is because they don't have a standardized way of working. Okay, like in organizations, you can enforce random things, you can enforce random policies, you can enforce developers to work in a certain way, you can train your developers. But when you're on an open source project wherein you're not like, you know, restricting whom you're accepting PRs from, or if you're getting like hundreds of PRs, and then there is no one like reviewing those PRs before kind of committing them, like reviewing from a security perspective, I would say. So we, like a year ago, we kind of we did a discovery exercise on a project wherein we started kind of, you know, putting a lot of open source projects, like creating CI/CD pipelines for open source projects, okay, wherein we can implement some basic SaaS task checks using GitHub Actions or things like that to at least have that basic sense. And I would say for open source projects, even if most of them have that basic CI/CD checks that can be implemented, that'll be a good enough like state to look at for now. And then once we are there, we can look at something else. But the problem is because there is a lot less control over who kind of commits code, who they are, like, you know, how they've learned coding. In companies, you can enforce a lot of secure development standards to people, but open source projects is difficult. Some projects do a good job in terms of like, you know, reviewing those PRs and kind of really getting what is coming in, and they constantly review the whole code base as well and do all those kind of things. But that's the problem, like, you know, most of, while I've talked about IBB, but IBB also covers the most like large scale projects. The small scale projects are not covered. As part of IBB, we've had conversations with hundreds of projects. And one of the things that we see is that they don't find it more like, you know, to start with valuable, because they think that the moment we say that we'll pay you bounties for finding bugs, they are already overwhelmed. They already are short staffed. They'll start to get more bugs and they'll not be able to fix those. Okay. So that's why they're reluctant of coming into programs like IBB to start with as well. So yeah, I think just like, you know, we are doing something for like bug bounty on open source, I think similarly there should be initiatives, or there can be more initiatives to push secure development at the same time as well. I'm like a big fan myself of that. So yeah, I think. Yeah, you can say.
Especially from the financing side, like how should they be more, like if my open source is secure, what benefit do I have to go into your program if I don't get any additional financing, but just as you said, more tickets?
So, sorry? Okay, so the question to repeat is that what benefits as an open source project do I have if my project is secure enough, if I'm following secure development standards and all those kind of things? Like, to be honest, like we keep saying, if the project is pretty confident that I have followed secure development standards, then there would automatically be less bugs. they'll not be bothered about those. Okay. But there would be bugs which would, if something has really passed the cycle of secure development and still that bug is discovered, that is something they really, really want to see. So the value of the bug kind of increases, the volume drops. So if you're really confident that, you've gone through secure development, the volume of bugs will definitely drop, but the value will increase. Okay. And yeah, that's, I think they'll not be overwhelmed for sure. And we've gone through this with a lot of projects. They don't get overwhelmed, but even like one bug they've received in 3 months or 4 months, that is something that they'll like to jump on immediately. And that could feed into their secure development practice as well. Like what did they miss or where did they miss to kind of, yeah. Okay. Any final question? Okay. We are on time as well. So we'll wrap it up. Thank you so much for staying, and it's lunch. So yeah, have a good lunch. Thank you.